Hello students, how are you everyone? This is Ram Sarov, your maths teacher. I welcome you all to our live classes children. Children, in the previous classes we have started the new chapter, that is linear equation in two variables. So in that we have discussed a few points children. So what can you please repeat me, what is the few points we have discussed in the previous classes? Yeah. The first one we have discussed was the introduction of what? A linear equation in one variable. Okay. And that we have discussed the solution of what? A linear equation of one variable. That means how many solutions can satisfy a linear equation in one variable. Can you tell me children, how many solutions it satisfy? So it satisfies only a single solution, isn't it children? A linear equation, one variable will satisfy only a single solution. If you want, you can take a small example children. Suppose I am taking x plus 3 equal to 0. Children, I need to what? Put the x value. So that I have to get LHS value is equal to what? RHS value. So what should I put children? I have to go for x is equal to a minus 3. If I substitute x is equal to minus 3, I will get LHS value is equal to what? RHS value. So I can say this x is equal to minus 3 is what children? The solution of a linear equation, one variable. Am I clear children this point? Okay. Then children, we have moved to what? The linear equation into two variables. Like what is the introduction of linear equation of two variables? Okay. So what is standard form? Can you tell me children what is standard form? The standard form is what children? Ax plus by plus c equal to 0. It is standard form of linear equation two variables, and one more condition. Here a is what? A not equal to 0. Are you getting my point children? Here a is what? Not equal to 0. And can you tell me children how many solutions a linear equation two variable has? How many solutions a linear equation two variable has? One solution or two solutions or three solutions? How many? Tell me children, the solution of linear equation of two variables, can you tell me how many solutions it can satisfy? So it can satisfy how many children? Infinitely many. So it can satisfy infinitely many solutions. Isn't it? Because the shape of the linear equation two variable is what? A straight line. Straight line means what children? It is formed by many points. So that every point is what? Lie on the straight line. So what I can conclude? So we can say all the points are the what? The solutions of linear equation two variable. Clear children this point, or any doubts? Okay. Now children, today we are going to discuss like some more extension children. So what we are discussing, let us see. The graphical method of what? Finding the solution of a pair of linear equation. Children, we are discussing what? A pair. Children, if you have think that you have the two equations, okay, you have the what? A two linear equations, like this is the equation 1 and equation 2. So for these two equations, we need to find the solution. Okay. So like which like we need to find the what? The pair of x comma y. So we need to find a pair of x comma y where it is satisfy the equation 1 and which satisfy the equation 2 both. So this pair of x comma y, what we can say children? It is a solution of the both the equation. Are you getting my point children? We need to find the what? The pair of x and y. So this pair of x and y will satisfy the equation number 1 and equation number 2. So that is called what? A linear equation two variable solutions. Like here pair I am taking, not a single equation. I am taking the what? The two equations. Okay. Now children, let us see how we are going to do this. And one more point children, we are discussing the relationship between the what? The coefficient and the nature of system of equations. Okay, these are very important children. Like how we can say, like how we can decide the equation, the pair of equation has single solutions or many solution or no solution. So that we have to discuss children. Like that we can identify easily without solving the equation. So for that we have to build some relationship children. So that relationship is called it is between the coefficients and the nature of system of equations. Okay. So these two things we are discussing children in the today's class. So let us see one by one children. First one, the graphical method of what? Finding the linear of equation two variables. Children, I think that you have the two equations. One equation is what? A1x b1y plus c1 equal to 0. A2x plus b2y plus c2 equal to 0. Okay, I have the two equations children. So this is also two variable and this also two variables, isn't it? Now when I am drawing these two equations children graphically, so how many combinations I will get children? This is a straight line. This is also a straight line. So I am drawing these two lines together in a single graph. So how many ways I will get? Like what is the representation of graphically? Or maybe they are straight lines, or maybe like crossed lines, or maybe parallel lines, or what? Tell me children, this total how many combinations I will get generally? See here. When these two lines are drawn in the same plane, so only one of the following three situations are possible. Exactly, we will get three situations, children. Three situations means what? The three cases. Only these three cases will be possible. When you are drawing the two lines at a time in the single plane, you are going to get the three situations. So what are those situations? Let us see one by one, children. Okay. The first case, children, like this. You think this is a line 1 and this is a line 2. In the first case, what happens, children? The two lines are intersecting, isn't it? It is the first case. In this case, the two lines are intersecting, and this point is called what, children? Intersection point. So this is what? A intersection point. And this intersection point we can take as what, children? It's a solution. Are you getting my point, children? So in this, we'll take this intersection point as solution. Okay. So in this case, we can take that intersection point is what? Solution. So that is a solution. Okay. See here. The two lines are what? Intersecting at one point. So it's the first case. In the first case, what happened, children? The two lines are what? Intersecting at one point. And it has only single solution, children, or we can say what? A unique solution, because the number of intersection points are how many? Here 1. So the number of intersection points are 1 means we can say it has a single solution. In case we are getting the 2 points are intersection. Okay. In case if you are suppose you are getting the 2 points are intersection, then the solutions are how many? 2 are solution. But we can get here only 1 point as a solution. So I can say 1 point is our intersection point. So I can say there is only one solution is a satisfy. So more than one solution you won't get here. Clear, children, this point? It has only a single solution, or we can say it is a unique solution, because the number of point of intersections are what? Single one. So one solution. Okay, that is the first one. Now children, second case. In situation 2, what happened? The two lines are not meeting, children. Okay, you can take this a line 1 and this is what? A line 2. In the second case, what happens, children? The two lines will not meet. Both are what? Like away from each other and exactly parallel to each other. So in this point, so can you tell me, children, what is the point of intersection? Do we have any point of intersection, children, in this case? So there is no point of intersection, because they are not meeting each other. They are called what? Non-intersecting lines. When the two lines are not meeting each other, if they are parallel to each other, so we can call them into a non-intersecting lines. So these two lines are what, children? Non-intersecting lines, or we can say parallel lines. So I can say these two lines are what? A parallel lines. Okay, children. So parallel lines means, can you tell me number of solutions are how many? The two lines are will not meet each other or will not intersect each other, so they are called parallel. So in these, the solutions are what, children? We can say no solution. Are you getting my point, children? There is a no solution. Why? Because the two lines are not meeting each other. When the lines are not meeting each other means obviously what we can say? They are not meeting, so they don't have any common solution. Okay. See, this is has some individual solution. This line also has some individual solutions. But common solution, no. Common solution does not exist because there is no common point. And they are not intersecting. So that's why what we can say, the number of solutions are what? 0. Solution does not exist. Okay, children? Fine. Next, children, another case. The two lines are what? Lying on another. So you can take this red color line as L1 and this blue color line is what? Something L2. Here one line is what, children? Lying on another line, isn't it? So I can say two lines are here coincide. So when the two lines are coincide, can you tell me what is the number of solutions, children? So here number of solutions are what? Infinitely. So we can say infinitely. The number of solutions are what? Infinitely, because all the points of line L1 and all the points of line L2. So both are what? Lying on both the lines. Okay. All the points are L1 and all the points are L2. So both are lying each other. The same points are Ln and the same points are L2. So both are lying same line. So in that case, what we can say, children? We can say the two lines are coincide. If the two lines are coincide means, we can say the number of solutions are what? Infinitely and many solutions. Okay, children? The number of solutions infinitely and many solutions. Okay. See, the two lines will be coincide. In this case, we have the infinitely and many solutions. So that is the answer, children. So we'll get only three types of like representation. First one is what? Intersecting. The two lines are intersecting. So you will get the one point as a common solution. The two lines are not meeting each other. So there is what? One line is what? Away from the each other. So both are what? Not intersecting. Other we can say both are parallel lines. In this case, what happens, children? The number of solutions are 0 because the lines are not meeting. Therefore, the solution is what? Does not exist. In the third case, both the lines are what? Coincide each other. So one line is what? Lying on another line, isn't it? So in that case, what we can say? The number of solutions are what? Infinitely, because both are coincide. The number of solutions are line 1 also satisfy the number of solutions for line 2 also. So I can say the number of solutions for the line 1 and number of solutions for line 2, both are what? Equal. So here I can say the number of solutions are what? Infinitely and many solutions. Clear, children, this point, or any doubts? Okay, fine. Next, children, let us see some example questions. Represent the following systems of what? Equations and graphically and find the comment on solution. Children, I want to find the solution of these two equations graphically, children. Okay, so how we are going to solve graphically? Let us see. First, I will take the first one. What is the first equation, children? X minus 2y equal to 0. So from this, what I am writing? 2y is equal to x, then y is equal to x by 2. Okay, children. Now, just write down the solution, children. I am writing directly. This is x and this is y. Children, I will take x is 0, so y also 0. I will take x is 2, then y is what? 1. I will take x is minus 2, so y is what? A minus 1. I will take x is minus 4, so y is what? A minus 2. I will take x is 4, then y is equal to plus 2. Clear, children? So the equation is what? X minus 2y is equal to 0 and 2y is equal to x and y is equal to x by 2. Then I am writing all the solution. So I am taking approximately 5 solutions. First 0, 0 is the one solution, 2, 1 and minus 2, minus 1 and minus 4, minus 2 and 4, 2. Clear, children? These are the solutions of the x minus 2y is equal to 0. Now, children, look at the second one. So 3x plus 4y is equal to 20. So what I am writing? 4y is equal to 20 minus 3x. Then y is equal to, so y is equal to what, children? Y equal to what? 20 minus 3x by 4. Now, children, substitute the x values and find the y value. This is x and this is y. So this is x, this is x and y. Okay. First one, children, you can take x is equal to 0. If you take x is 0, so 3 into 0, 0. So 20 minus 0, 20. 20 by 4 is equal to 5. So this is 5. Okay, children. Next, I'll take x is equal to 2. So 2 means 3 into 2, 6. So 20 minus 6. What is 20 minus 6, children? Is it possible to divide? It is not possible, children. So we'll do one thing. I'll take some other value. Let us see. I'll take x is equal to 4. So 3 4s are 12. 20 minus 12 is equal to 8. 8 by 4 is equal to 2. So I'll take the point is what? A 4 comma 2. Clear, children? So another point I'll take as something minus 4, children. Let us say minus 4. So minus 4 means it is minus 3 minus 4. So minus 3 into minus 4 is plus 12. So 30 plus 12 is equal to what? Sorry, 20 plus 12 is 32. So 32 by 4 is equal to 8. So minus 4 and 8 is a one more solution. Clear, children? So I am writing all the solutions of the first equation and second equation, isn't it? Now children, let us draw the graph. So graph me already know, so this is a horizontal line x-axis and vertical line is y-axis. Okay. Now children, first I am drawing the equation 1. So I'll take the different color. Okay. First is what? Coordinate 0 comma 0. So this point is what? Is 0 comma 0. And second point 2 comma 1, x is 2 and y is 1. Next point minus 2 comma minus 1. So it is minus 2 and minus 1. And next point minus 4 and minus 2. Minus 4 and minus 2. Next point 4 comma 2. So this is a 4 comma 2. Clear, children? Then children, join all the points with a straight line. Okay. So what is the equation of this line, children? X minus 2y is equal to what? 0. So that is the first equation graphically. Now children, let us draw the second line also. Second line will take some other color. Okay. So what is second color? X is what? 0 and y is equal to 5. So I can say this is a solution. Next 4 comma 2. X is 4 and y is equal to what? 2. Next one, x is minus 4, y is what? 8. X is minus 4, so y is equal to something 8. Okay. Next, children. That's it? Okay, fine. Children, join this. So this is a second line. So this is a, what is the equation of this line, children? 3x plus 4y is equal to 20. Clear, children? Now children, once look at the graph, can you tell me what type of these two lines? Can I say these two are intersecting lines, children? Yes or no? The line 1, like x is equal to minus 2y is equal to 0, and line 2, 3x plus 4y is equal to 20. So these two are what, children? They are intersecting lines. So intersecting line means they have how many solutions? So when the two lines are intersecting, they will be having a single solution. So I can say this is a one solution, children. So what is this intersection point, children? This intersection point is what? A 4 comma 2. Here x is 4 and y is 2. So this is called what? The solution. Okay. So this is a solution. So this solution is what? A 4 comma 2. So children, the same way we can find other questions also. So here we are finding the what? The solution of the equation by graphically. First, I am taking the first line, children. I am writing all the coordinates like solution, and second equation, I am drawing all the coordinates. Then I am drawing the two graphs. After drawing, I got the one point of intersection, children. That is what? A 4 comma 2. These two lines are what? Meeting at one point, that is a 4 comma 2. So I can say the 4 comma 2 is the what? A solution of the equation. Because here the two lines are what? Intersecting lines. When the two lines are intersecting lines, mean the number of solutions are what? Only single solution. Okay. So I can say this 4 comma 2 is a what? Solution. Okay. So that is the answer, children. That's it. Nothing is there to solve here. Afterwards, you can write the scale. So scale what you are taking? X-axis. So 1 centimeter is equal to you are taking only 1 unit. Even y-axis also 1 centimeter. Again you are taking only 1 unit. Obviously that you can write every time. So here also write down, children. Okay. See, children, any doubts regarding this question? Question is very simple, children. Okay, like previous only, like already we drawn the many like equations graphically, but here I am doing two lines at a time. So when you draw the two lines at a time, so there will be three situations already we discussed now. So one will be what? Intersecting lines, second condition will be parallel lines, and third condition will be the two lines are coincide. So here I got the two lines are intersecting. Okay, so the number of solutions is 1. So that solution is a 4 comma 2. Okay. Now children, let us take this question also. 2x minus y is equal to 4. Children, here also they have given the two equations. One equation is what? A 2x minus y equal to 4. And we need to find the what, children? The solution of the equation. Okay. See what I am writing. 2x minus y is equal to 4. So this I am writing y equal to 2x minus 4, isn't it? So 2x minus y is equal to 4. I am writing y is equal to what? A 2x minus 4. Now children, substitute x value and y value. Okay. So bring only 3 to 4 solutions, not many, children. Because if you want to draw the any line, so minimum we require that only 2 points, isn't it, children? So take x and y. Children, first I'll take x is 0. If I take x is 0, what is the y value, children? It is a minus 4. So x is 0, y is equal to minus 4. I'll take x is 1. So 2 minus 4. What is the 2 minus 4? It is minus 2. Then I'll take x is minus 1. So minus 1 means 2 into minus 1 minus 2, and minus 2 minus 4 is minus 6. Then I'll take x is equal to what? Something 2. 2 to the 4. And 4 minus 4, it is 0. So if I take x is 2, so y value is what? 0. Clear, children? These are the points. Next, look at the second question, children. 4x minus 2y is equal to 6. So 2y I can write as 4x minus 6. Then y is equal to 4x minus divided by 2. So if I cancel the 2, so what I will get, children? I will get 2x minus 3. Okay. Like 2 1s are 2 2s are, and this 2 1s are 2 3s are. Okay. Again, children, draw the solution box. Same like previous only. So take this is x and take this is y. Children, first take x is 0. 0 means 2 into 0, it is 0, and 0 minus 3 is minus 3. So this is 0 and minus 3. And take x is 1. So 2 minus 3. What is 2 minus 3? It is minus 1. And take x is what, children? It is minus 1. If take minus 1, so 2 into minus 1 minus 2, and minus 2 minus 3, it is minus 5. So this is a minus 5. Okay, children. So let it be 3 points are enough, because 2 points are enough, children, to draw the any like graphical equation. So 2 points are enough. So I'm finding the 3 points. So let us stop there only. Okay, fine, children. Let me draw the same graph. Now again I'm taking the what? The graph. First draw the first equation and draw the second equation. Okay, for that I'm taking the different line, children. So first equation. So what is the first equation, children? The solution. First solution 0, 4. X is what? 0. X is a 0 and y is equal to what? 4. So minus 4. So the point is here. Next to x is 1 and y is minus 2. X is 1 and y is minus 2. So the point lying here. X is minus 1 and y is equal to minus 6. X is minus 1 and y is equal to minus 6. The point is lying here. X is 2 and y equal to 0. X is 2 and y equal to what? 0. So I can say this is a point. Okay, children. Now children, join all the points again same manner with help of the scale. See, you will get the line like this. So this is a line. Okay, children. So what is the equation of this line, children? We can say y is equal to 2x minus 4. So that is the first equation. Now children, look at the second equation. What is the solution, children? Second equation. Second equation of the same manner only. So first x is equal to 0 and y is equal to minus 3. X is equal to 0 and y is equal to minus 3. X is equal to 0 and y is equal to minus 3. Next, x is equal to 1 and y is minus 1. So it is minus 1. X is equal to what? Minus 1 and y is equal to minus 5. X is equal to what? Minus 1 and y is equal to minus 5. Okay, it is the equation, children. So again I am joining all the points one by one. So this is the equation 2, children. So what is the equation 2? 4x minus 2y is equal to 6. 4x minus 2y is equal to 6. So this is the equation 2. Okay. Children, once you look at the graph here, we have exactly 2 lines. And the 2 lines are not meeting each other, isn't it, children? So if they are not meeting each other means, can I say these two are parallel lines? Because there is no point of intersection. In case if we extend on both the direction children, the two lines they are not going to meet each other. Yes or no? So I can say these two lines are what? A parallel lines. I can say these two are what? A parallel lines. Children, when the two lines are parallels, can you tell me what is the number of solutions? So how many solutions it can satisfy, children, when the two lines are parallel? Tell me, children, there is no point of intersection between the two lines. So what is the common solution then? So here common solution is what? No solution here. I can say here it is no solution. Otherwise we can say solution does not exist because the two lines are parallel. When the two lines are parallel means the number of solutions are what? 0. Otherwise we can say the solution does not exist. Am I clear, children, this point? The solution is what? Does not exist. The number of solutions are what? 0. Clear, children, my point? The number of solutions are what? 0. Otherwise, the solution does not exist because the two lines are parallel to each other. Okay, so I can say here what? The solution does not exist. Am I clear, children, this point, or any doubts? Okay, because the two lines are parallel, we can say directly the solution is not exist. Now, children, let us see another question. Okay, children, now relationship between the what? The coefficient and the system of solution. Children, I am taking the first the two linear equation, one variable, a pair of linear equation. So this is a1x plus b1y plus c1 equal to 0. I am taking another equation, a2x plus b2y plus c2 equal to 0. Okay, children. Now what I am doing? I am finding the what? The ratio of the coefficients, corresponding coefficient, like coefficient of x here, coefficient of x here, y and y here, constant and constant, isn't it, children? So let us find all the ratios. So one ratio is what? a1 and a2, another ratio b1 by b2, next ratio and c1 and c2, isn't it, children? Now what I am doing? First I am comparing all the coefficients. Suppose if I get a1 is not equal to b1 by b2. Okay. And second comparison is what? If a1 is equal to a2, a1 by a2 is equal to what? b1 by b2 and not equal to c1 by c2. Then another comparison is what? a1 by a2 is equal to b1 by b2 is equal to c1 by c2. It's the third comparison. Okay, children, so we have the exactly three comparisons like ratio of their coefficients. Children, in the first comparison, a1 by a2 is not equal to b1 by b2. In this in this situation, what we can say, children? So in this situation, like in this ratio, we can say the solutions are what? One solution. Otherwise, we can say consistent. If the ratio of a1 by a2 and the ratio of b1 by b2 is not equal, then you can say the solution system is what? Consistent. Consistent means the number of solutions are what? How many? One is the solution. So we can say consistent. Are you getting my point, children? If a1 by a2 is not equal to b1 by b2, so we can say consistent. Therefore, we can say the number of solutions are how many? One is the common solution. Next one. a1 by a2 is equal to b1 by b2 and not equal to c1 by c2. Here I can say inconsistent. Children, consistent means there is a solution. Inconsistent means there is no solution. Here we can say there is no solution. Okay. Here I can say what, children? No solution. So consistent means there is a single solution. Inconsistent means there is no solution. So when no solution, children, a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. So when you are getting the combination is like this form, so we can say the number of solutions are what? 0. We can say inconsistent. And next comparison is what, children? a1 by a2, b1 by b2 equal to c1 by c2. Here we can say consistent but dependent, because here we are getting the many solutions here. So I can say many solutions. I can say this is what? A many solutions. Clear, children? We can say many solutions. Many solutions mean the number of solutions are what? Many. So here I can say inconsistence. Inconsistence. This is a consistent and it is inconsistent. Consistent means there is single solution. Inconsistent means there is many solution, or we can say dependent also. We can say here dependent. Okay. Clear, children, the ratios and comparisons and the relationship. In the first one is what, children? A1 by A2 is not equal to B1 by B2 means we will get this one solution. In the second case, A1 by A2 is equal to B1 by B2 but not equal to C1 by C2 means we can say no solution. Here it is called what? Inconsistent. If A1 by A2 equal to B1 by B2 equal to C1 by C2, then what we can say, children? We can say, so this is consistent only. This is consistent, but we can say dependent solution. This is what? Inconsistent. Okay, children? See here clearly. See first one. A1 by A2 is not equal to B1 by B2. So what we can say? We can say consistent, that is independent. And what is the nature of line, children? We can say intersecting, and the number of solutions are what? A single solution. We can say one solution. Next one, A1 by A2 is not equal to B1 by B2 is not equal to C1 by C2. We can say inconsistent, then the lines are what? A parallel lines. In that case, the lines are what? Parallel lines, and the solution is what, children? We can say a no solution. The second case. And third case, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Then what we can say, children? We can say consistent but dependent. Consistent but dependent. Here the solution is what? Sorry, here the lines are what, children? We can say coincident line. So one line is what? Lying on another line. So we can say coincide. And what is the solution here, children? We can say infinitely many solution. Okay, we can say the solution is what? Infinitely and many solution. Okay, children. So children, try to remember these three conditions. So based upon these three conditions, we are going to solve the questions. Whether the solutions of equations are what? Infinitely or many or unique. Okay. So the based upon this condition only. First one, A1 is not equal to B1 by B2 and A1 is by A2 is equal to B1 by B2 is not equal to what? C1 by C2. And next condition, A1 by A2 is equal to B1 by B2 and equal to what? C1 by C2. So based upon these three conditions only we can decide whether the lines have single solutions or many solution or no solution. Clear, children? So what I am telling you, just try to remember these three solutions, select three conditions. Okay. Now children, let us see one question here. Check whether the given pair of equations represent the what? Intersecting lines or parallel lines or coincident lines. Okay, children, let us do one. First, what is the given equation, children? First one, 2x plus y and minus 5 equal to 0. And second equation is what, children? 3x minus 2y minus 4 equal to 0. Children, first compare, like write down the a1, b1, c1 value and a2, b2, c2 value. For first equation, what is the a1 value, children? So a1 is equal to 2 and b1 is equal to what, children? So b1, yeah. So b1 is equal to 1 and c1 is equal to what? A minus 5. In the second equation, a2 is equal to what? A3. b2 is equal to minus 2 and c2 is equal to what? A minus 4. Isn't it, children? Then find out first one. What is the first condition, children? Check the first condition. So a1 by a2 is what? Not equal to b1 by b2. If it is satisfied that condition, children, you can stop it there only. You can end the problem itself there. If it is not satisfying this condition, go for second condition. Okay. If second condition also not satisfying, so go for third condition. So out of three conditions, so one condition definitely will satisfy, children. Okay. Now I am going for first condition. So I will check a1 by a2 is b1 by b2. So what is the a1 by a2, children? So this is 2 by 3 value. Then I will finding the b1 by b2 value. So b1 by b2 nothing but, so 1 by minus 2 we can say minus 1 by 2. Then I am checking c1 by c2. So c1 is equal to minus 5 and c2 is equal to minus 4. So we can say it is 5 upon 4. So a1 by a2 2 upon 3, b1 by b2 minus 1 by 2 and c1 by c2 is 5 by 4. Children, just look at the values a1 by a2 and b1 by b2. So a1 by a2 is 2 by 3, b1 by b2 is minus 1 by 2. So I can say, children, directly. So what we can say directly? a1 by a2 is not equal to, I can say, b1 by b2. Am I clear children this point? I can say a1 by a2 is what? I can say directly not equal to b1 by b2. So a1 by a2 is not equal to b1 by b2 means, so what is the conclusion children? I can say unique solution. So what I can say? I can say it is unique solution. Because the two lines are what? Intersecting. Here what is the nature of the lines? Nature of the lines are what? Intersecting lines. Here I can say the nature of lines are what? Intersecting. So intersecting means what? It has unique solution. Okay children? Because it is satisfying the first condition. a1 by a2 is what? Not equal to b1 by b2. I can say it has a unique solution, or we can say single solution. And nature of the lines are what children? We can say intersecting lines. See. So that is the nature of the lines. Intersecting lines is the answer. Clear children? Any doubts regarding this question? Okay, let us see another question children. One more. Check whether the following pairs of linear equation consistent. Again same type of question children. We have to check whether the given is what? Consistent or not. Whether consistent, how many solutions? If inconsistent means there is no solution. Now, so this is a 3x plus 4y is equal to 2, and this is 6x plus 8y is equal to 4. Now children, write down the a1 value, b1 value, c1 value. a1 is equal to 3, b1 is equal to 4, and c1 is equal to 2. Here a2 is equal to 6, b2 is equal to 8, and c2 is equal to 4. Okay children. Now find out a1 by a2. So what is a1 by a2 children? That is 3 upon 6. So this is 1 by 2. Find out b1 by b2. So b1 value 4 and b2 value 8. So this is 1 by 2. And find c1 by c2. c1 value 2 and c2 value 4. So it is 2 upon 4. So we can say 1 by 2. Clear children? See children, here a1 by a2 also 1 by 2, b1 by b2 also 1 by 2, c1 by c2 also 1 by 2. So children, here three values are equal means, can I write a1 by a2 is equal to, I can write as b1 by b2 and I can write as c1 by c2. Clear children? See here a1 by a2, b1 by b2 and c1 by c2, the three ratios are equal here. If the three ratios are equal means, so what is the conclusion? So what conclusion you can say? We can say that is inconsistent. Sorry, consistent, but this is a consistent, not inconsistent. That is called what? Consistent. Consistent but dependent. Consistent, but we can say dependent. Consistent but dependent. So dependent means, can you tell me how many solutions it has? It has many solutions. So many solution means what children? So one line is what? Lying on another line. If one line is lying on another line means, so what is the conclusion directly? We can say infinitely many solution is our final answer. Are you getting my point children? Here we can say infinitely many solutions. So one line is what? Lying on another line. So a1 by a2 equal to b1 by b2 equal to, we got something c1 by c2. So this is called what? A consistent and we can say dependent. So we can say it satisfies the many solutions. Am I clear children? This answer or any doubts? Question is very simple children. So they have given the two equations. So it's the first equation and it is second equation. And try to render the a1, b1, c1 value and a2, b2 and c2 value. Later find the ratios. What is a1 by b2 value and b1 by b2 value and c1 by c2 value. Okay. So after that just do the comparison. I am getting what? a1 by a2 is equal to b1 by b2 is equal to, I am getting c1 by c2. Then check which condition is satisfied among the three conditions. So directly I can say children, the third condition will satisfy. The third condition is what? a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So based upon the third condition, what we can say? It satisfies infinitely many solutions. Isn't it children? Yes. Next, see, let us see one problem here. Check the given solution is a unique solution or infinitely solution or no solution. And children, same type of question this also. Okay. First, what is the given, children? Equations. Otherwise, you can write standard form also. How we can write standard form? You can write as 2x plus 3y minus 1 equal to 0. Or you can write as 3x minus y or minus 7 equal to 0 also. You can write any manner, children. Plus c is equal to 0 or equal to c form also. Then write down the values here. First, a1 value. What is the a1 value? 2. b1 value, this is 3. c1 value, it is what? A minus 1. Next, a2 value. What is the a2 value? 3. b2 value, it is minus 1. c2 value, it is minus 7. Okay. Now, children, find the ratio. a1 by a2, that is 2 upon 3. So, b1 by b2, what is the ratio, children? That is 3 upon minus 1. So, we can say minus 1 by 3. Now, children, find the ratio c1 by c2. Minus 1 by minus 7, that is 1 by 7. Okay, children? First, a1 by a2 and b1 by b2, and this is what? A c1 by c2. Now, just children, look at the a1 by a2 and b1 by b2 ratio. What is the first condition, children? a1 by a2 is not equal to b1 by b2. Just check it, children, whether it is satisfying or not. So, a1 by a2 is equal to 2 upon 3 and b1 by b2 is equal to minus 1 by 3. So, clearly we can say, children, it satisfies the first condition. a1 by a2 is not equal to what? A b1 by b2. If a1 by a2 is not equal to b1 by b2 means clearly we can say the first condition is satisfied. If the first condition is satisfied means, so what we can say, children? We can say directly it has a unique solution. Yes or no? So, it has what? Directly a unique solution. So, unique solution means we can say it is consistent. So, we can say it is a consistent. It has a unique solution. So, I can say it has single solution and it is a consistent. Clear, children? Any doubts regarding this question? First, find out the a1, b1, c1 value and a2, b2, c2 value. So, later just compare the coefficients like a1 by a2, b1 by b2, like find the ratios. So, after finding the ratios and try to find out the like where it would fall, whether the first condition like first statement, second condition or third condition. So, I can say, children, directly it falls on the first condition only. What is the first condition? a1 by a2 is not equal to what? b1 by b2. Okay. So, we can say here consistent. So, consistent means we can, what is the condition, children? We can say it is a unique solution. So, I can say it is a unique solution or we can say single solution. Now, children, look at this question, the same manner, children. I can find out the a1, b1, c1 value and a2, b2, c2 value. So, I am writing, children, a1 value. So, a1 value is equal to 1. X coefficient is what? 1. Next, b1 value is equal to 2. And c1 value is equal to what? 6. Next one again, a2 value 2 and b2 value 4, c2 value it is 12. Okay. Now, children, find out the ratio a1 by a2. So, I can say 1 by 2. So, b1 by b2. So, that is what? A2 by 4. So, this is again 1 by 2. Isn't it, children? And next one I am writing c1 by c2. So, this is what? A 6 by 12. So, 6 by 12 means again we can say 1 by 2. Children, I got a1 by a2 is 1 by 2, b1 by b2 also 1 by 2, c1 by c2 also I got 1 by 2. Clear, children? So, I got, children, the three ratios are equal. The three ratios are equal means, can you tell me, children, which condition is satisfied? Third condition. Like a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So, children, I can say clearly it is satisfying a third statement, like third condition. Third condition is what, children? a1 by b2 is equal to b1 by b2 is equal to c1 by c2. So these three are equal means, so what is the condition, children? We can say it is consistent and dependent. Consistent and dependent, isn't it, children? So consistent and dependent means, so what we can conclude, children? We can conclude only one thing. So what we conclude directly? It has how many solutions? Infinitely many solutions. So it has infinitely many solutions. So we can say it has infinitely and many solutions. Clear, children, this point, or any doubts? Because it is satisfying the what? The last condition. So a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Okay. Children, these questions are very simple, children, and this is I can say compulsory question also. First, the given equation. So what you have to find out? So first find the coefficients. So like a1 by a2 and b1 by b2 and c1 by c2. So after finding the a1 by a2, b1 by b2 and c1 by c2, so what you have to do? Just check the conditions. So out of three conditions, which condition will satisfy? From that, just check which condition is satisfied, and based upon that condition, give the conclusion, like give the result. Whether the first result or second result or third result. First result is what? A unique solution. And second result is what, children? No solution. And third condition is what, children? a1 by a2, b1 by b2, c1 by c2 are equal. So directly we can say consistent, but how many solutions? It has infinitely many solutions. Okay, children. So infinitely many solution means what is the nature of the line, children? We can say parallel lines here. Okay. We can say the nature of lines are what? Parallel lines. Clear, children? Any doubts regarding this class? So today's class we are discussing about what? The graphical representation of the pair of linear equation, two variables, and second one is what, children? The relationship between the coefficient and the nature of solution. Okay, so that is the point we are discussing today's class. Fine, children, I hope you understood this class. Okay, so children, try to practice the more questions, so it will be easy for you, children. Okay.